Today we're going to talk about angular speed and linear speed. So we have a couple of formulas to look at before we start. So this symbol is an omega symbol, and omega is equal to theta over t, which is your angle measured in radians divided by the time. Your linear speed is your velocity equals distance over time. When we talk about angular speed and linear speed, we're talking about the speed of a point going along the circle on the outside edge of the circle. So traveling along an arc length. So when we talk about linear speed, the distance over time is the arc length, otherwise known as s, over the time. And the angular speed is how big of an angle theta is divided by time. All right, as a reminder of arc length, s equals r times theta, or your arc length is your radius times your angle in radians. Here's your radius, here's your s. And the relationship between angular speed and linear speeds is velocity equals radius times the angular speed, or v equals r times omega. All right, so for our examples, it says to find the angular speed. We're going to do that as part A, and then we're going to find the linear speed. That will be part B. And then the linear speed of a point that's halfway between the center and the circumference, that'll be part C. So we're going to do 3 parts for each of these questions. For the first one, we're going to find the angular speed in radians per second, but the speed is given to us in revolutions per second, so we have to do some converting. So we know that it's omega equals theta over t, so we need to figure out how to convert 15 revolutions per 1 second into radians per second. So each revolution around a circle, if you think about traveling all the way around a circle, that measure of the angle in radians is 2 pi. Well, that's 1 revolution. So each 1 revolution is equal to 2 pi radians. And as a reminder from dimensional analysis, we want to try to get our units to cancel out, so the revolutions will cancel out. All right, so now we're going to multiply across, and we get 30 pi radians per second, which is our answer. So for part B, we're going to use the formula velocity equals distance over time, or arc length over time. And so the information that's given to us for arc length, we need to know the radius times the angle. And so the angle is also known as the angular speed in this situation. And so we're going to look at the 20 centimeter radius times the angle, which we decided in part A was 30 pi radians per second. And so if you were to multiply that out, you get 600 pi centimeters per second. And we can leave off the radians. So now look at your units and make sure that you have the correct units, which we do. All right, in part C, it's essentially the same question as part B, except for a radius, we're going to choose a point that's halfway between the center and the circumference. So your center and the edge of the circle are there. If the entire radius is 20, then we have a point that's exactly halfway. Then it should be split up into 10 and 10. And so we're going to use 10 centimeters as our radius now, and it's going to have the same angular speed as we did from before. So that's going to give us 300 pi centimeters per second. And again, you can leave off the radians. All right, for number 2, we're going to do another 3-part question. The only difference here is that they provide us with 2,160 degrees per second for your angular speed, and before they gave us revolutions per second, but we want our final answer to be in radians per second. So you really just have to be careful of your units in this problem. So omega is equal to the angle divided by the time. And we need our angle in radians. So when we have 2,160 degrees, we first need to convert that into radians. So pi radians is equal to 180 degrees. So we can simplify that in our numerator. And then that's measured as 2,160 degrees per 1 second. All right, so now you just have to simplify. So our degrees will cancel out. And if you reduce 2,160 divided by 180, you get 12. So it's 12 pi. We know this is measured in radians per second. All right, so we're going to use this answer to do part B, which is our velocity equals distance over time. So our distance is our arc length, and arc length is the radius, which they provide us with 60 centimeters, times our angle, which we figured out was 12 pi radians per second. Okay, so now you're going to simplify, and 60 times 12 is equal to 720 pi centimeters per second. And again, you can leave off the radians when you don't need it. For part C, it's the same concept, except remember we're using a point that's halfway between the center and the circumference. So our radius is now going to be 30 centimeters, but the same angular speed as part B from part A. So that gives us 360 pi centimeters per second. And again, you can leave off the radians. All right, so for number 3, we have our omega equals the angle measured in radians over time. So when they provide us with the 1250 revolutions per minute, let's change revolutions into radians, and every 1 revolution is going around the circle 1 whole time, so that would be 2 pi radians, and that is per 1 minute. But now we don't want 1 minute, we want to measure this in seconds, so we know that in every 1 minute there are 60 seconds. So just be really careful with your units, and then cancel out wherever you have the same unit in the numerator and denominator. So now we end up with 2,500 pi radians for every 60 seconds. And then let's just reduce, and that becomes 125 over 3 pi radians per second. So that's your angular speed. When you go on to part B, we're going to use that answer for our velocity equals distance over time. So in this case, we have 10 centimeters as our radius, and we're going to multiply that by our angular speed. So now when we do that, we are left with 1250 pi over 3 centimeters per second. You can leave off the radians part. And then in part C, we're going to do the same thing where velocity equals distance over time, except the point that's halfway between the center and the circumference, it has a 5 centimeter radius, but the same angular speed of 125 pi over 3 radians per second. So now when we multiply that, we get 625 pi over 3 centimeters per second. All right, so as we take a look at our unit circle, which is our circle with a radius of 1 unit, we can look at quadrant number 1, and remember from what we did yesterday, converting from radians to degrees, I've labeled all of the angles in degrees and all of the angles in radians. So let's focus only on the first quadrant for now. So if this point at the center of the circle is 0, 0, then the ordered pair, my radius is 1, then I go out 1 unit to the right and up or down 0 units. If I look at the 90-degree angle, I would go left or right 0 units and up 1 unit. So that has an ordered pair at 0, 1. All right, so if I look at my 45-degree angle, for example, that has a point that's 1 unit away from the center. That's my hypotenuse. And if I were to draw a line straight down to the x-axis, I can create a right triangle. And this angle is 45 degrees. All right, so let's recall geometry where we had 45, 45, 90 right triangles. We know that if our hypotenuse is 1, then our two legs have to be equal to each other. And so if I did x squared plus x squared equals 1 squared, I would get 2x squared equals 1, or x squared equals a half. And if I were to take the square root of that, I get 1 over root 2, which we would need to rationalize, and that would give us root 2 over 2. So each of these legs are root 2 over 2. So I'm going to label this ordered pair as root 2 over 2 comma root 2 over 2. So if you look at the other angles that create a 45-degree angle with the x-axis, we have essentially the same triangle, except it's in quadrant 2, which means that from the origin, I go left root 2 over 2, but up root 2 over 2. And then in the third quadrant, I go left root 2 over 2, and then down root 2 over 2. So notice that both of those coordinates are negative. In quadrant 4, I would go to the right root 2 over 2, and then down root 2 over 2. All right, so let's continue looking at the 90-degree multiples. So we looked at 0 and 90. If we go to 180, that's 1 unit away, so I go 1 unit to the left and 0 units up or down. For the 270 degrees or 3 pi over 2 angle, we go left or right 0, but down 1 unit. So now let's look at the 30-degree angles, and we're going to create a right triangle with the x-axis in the first quadrant. We know that our hypotenuse is equal to 1, and if you recall from geometry, if you have a 30-degree angle, then you have a 60-degree angle. So this would be a 30, 60, 90 special right triangle. All right, so the 30, 60, 90 special right triangle has n root 3, and 2n as its sides. And so if we know that the hypotenuse is equal to 1, then n is really equal to 1/2. So this side is 1/2, and this side is 1/2 root 3, otherwise known as root 3 over 2. So that means that from the origin, in order to get to this point, I would go root 3 over 2 and then up 1/2. So now let's complete all of the triangles that have a 30-degree angle with the x-axis. So this is just a reflection of the same triangle. So I would go negative root 3 over 2 and up 1/2 for the 150-degree angle. For the 210-degree angle or 7 pi over 6 angle, I would go left root 3 over 2 and down 1/2. And for the 330-degree angle or the 11 pi over 6 angle, I would go root 3 over 2 and down 1/2. All right, so finally we're going to look at the 60-degree angle, and that makes a triangle with the x-axis that has a radius or hypotenuse of 1 and an angle at the origin of 60 degrees. So if you think to geometry, if we have a 60-degree angle in the bottom corner, then across from the 60-degree angle, that's our n root 3. Across from the 30 is the n, and then our hypotenuse is 2n. So again, n was equal to 1/2. So this bottom side is equal to 1/2, and this side on the right would be 1/2 root 3 or root 3 over 2. So if we were to label this point, we would have to go over 1/2 and up root 3 over 2. So now we're going to continue with any other triangle that's created with the x-axis that creates a 60-degree angle at the origin. So at the 120-degree angle or 2 pi over 3 angle, you have negative 1/2 comma root 3 over 2. At the angle that's 240 degrees or 4 pi over 3, that gives you negative 1/2 and negative root 3 over 2. And then for our final angle, we have 300 degrees and 5 pi over 3, which gives us 1/2 and negative root 3 over 2. All right, so this is your completed unit circle, and we're going to use these ordered pairs throughout the rest of the chapter. So please make sure that you have this filled out. If you have any questions, please talk to your teacher. Have a nice day.